Hello, when we solve logarithmic equations, we often run into four different possibilities. So let's look at each one and see how to solve. One possibility is we might get just an exponential expression, and the way to solve it is to switch to logarithms because logarithms undo exponents, and then we would be able to get our answer. But first, we need to get to the exponent and get it by itself. So following the order of operations, we need to undo multiplying by 2 and divide both sides by 2. So if we do that, we're going to get divide by 2, divide by 2. So now we have 3 to the power 5x is 27. Now at this point, we switch to logarithms. The base is 3. So our log is going to get base 3. And then the input and the output switch place. So right now, 3 is with a 5x, it'll switch and 3 is going to get 27. And the 5x is on the other side. Now with the calculator, we can figure out what is log 27 base 3. So here's the calculator. And we can go to the math and then scroll until we see log of any base. Here it is, choice A, and then we type in our question, log base 3 of 27, and the answer should be 3. Because 3 to what power makes 27? Well, 3 cubed makes 27. So the answer to that is 3. Now we have 3 is 5x, and to get x by itself, we divide both sides by 5, and here is our answer. X is 3/5. That's the first possibility. The second possibility is we might get, instead of one exponential, we might get the question reversed and we might get one logarithm. Well, in that case, we switch back to the exponential because inside of our log there is an unknown and we can't put this in the calculator and get the answer because we're looking for this x. This x has to be out of the logarithms, and the only way to do that is to use exponents. So we reverse the same steps we just took here. We keep the base on the bottom, and we switch the input and the output, giving us 3 to the 4th is x. Well, 3 to the 4th we can type into the calculator, 3, and it would be 81. Just to confirm, 3 to the power 4 is indeed 81. So that's the answer. X is 81. So that's the first two cases. The third case is we might get one log per side with the same base and nothing else. And that's very important that there is nothing else. Because if there was anything else, we would not be able to use this method. But if that's all we have, then realistically, if we look at the both sides, logs are the same. The only way to make these two halves equal is the inside of log must be equal to inside of this log. Meaning we can simply ignore the logs altogether and simply solve x minus 1 is 12. Adding 1 to both sides, we get our answer. X is 13. We can also use a different approach to solve this same question, and it uses the procedure known as exponentiation. So you can exponentiate something, meaning turning it into the exponent. So here is the original question. Let's write it back. So here a little bit below, scroll up, log base 3 of x minus 1 is log base 3 of 12. Well, if we make both of these halves powers of base 3, like so, 3, 3, and then this equals now is in between, that would still be a true statement. Why? Because if we had 2 is x, then 3 squared is 3 to the x. That would be a true statement. Or if you take anything else and it was equal to begin with, and you make it exponent, it would remain equal. But now, because we have the same base and we are raising raising the 3 to the log of base 3, when the bases are the same, they cancel each other off and just give us what's inside the parentheses, and that simply takes us back to the same step we had before when we dropped the logs. So that would be sort of explaining mathematically why ignoring the logarithms actually works, because we can use the procedure of exponentiating and get exactly the same result, and x is 13, just like before. Now the last possibility is we get something else. We might get something more than just 1 log per side, and as long as they have the same base, we combine them into one logarithm, and then we will get one of the previous 3 cases, and we'll go from there. But the key thing here is when we get the answers, we have to check, make sure they work, make sure we didn't pick up any extraneous solutions that don't work. And the way we check them is we put them back into original question and see if the inside of the logarithm is negative or 0. If it happens, then we have extraneous solution, because inside of log is always positive. It can never be negative, it can never be 0. If that happens, that's not a solution, it won't work. So let's solve it. The first thing to do, since we have the same base, is we combine the 2 logs into 1, remembering that the plus turns to multiplication, which means log base 2, x plus 1, x minus 1 is 3. Now at that point we just have a logarithmic question that we don't know how to solve. That would be case number 2. Case number 2, 1 logarithm equals something and the unknown is inside of the log. That's exactly what we have. And the method is we switch to the exponential form. So here it goes. We keep the base on the bottom and we switch the input with the output. So 2 gets the 3 and the rest of the question goes on the other side. Well, 2 to the third happens to be 8. Now we multiply through to see what else we have. X times x is x to the 2. X times negative 1 is negative x. 1 times x is positive x. 1 times negative 1 is negative 1. X's cancel off, making 8 equals x squared minus 1. To get x squared by itself, we add 1 to both sides, making 9. And then to cancel the square, we use square root of both sides. So x is plus minus square root of 9, because there will be two answers, and they are plus minus 3. So now we have our 2 solutions. We have x is 3 and x is negative 3. But if we try to plug in negative 3 inside of our original expression, then here we have negative 3 plus 1. That makes negative 2 on the inside. That won't work. And of course here we get negative 3 minus 1, that's negative 4. So the negative 3 is extraneous solution, and we can't use it, we have to toss it. On the other hand, if we have plus 3, that works, because plus 3 minus 1 stays plus 2, and 3 plus 1 is 4. So we only get one answer, and that is x is 3. We can also use a calculator to check. So let's type in the left side as one equation, the right side as a second equation, and see where the 2 sides are equal, that is, where the 2 graphs cross. So here is the calculator, and y equals. So we will be using log of different base, so let's scoot over to choice A, log base 2, and here we have x plus 1, and then on the other, and then plus, go back to log, If we don't have the log base anything on our calculator, then we have to use the change of base formula to do the same, and it will work. We just have to type in two separate logarithms where we have one. And then on the other side is 3. So let's see where they cross. Here comes the log, eventually, there it is. And there comes the 3. And we can see that they cross only once. So the two solutions don't make sense visually because there is no way this curve is coming back to cross with a straight line. Now, where did they cross? Let's find that intersection. Second, calculate, intersect, and let's go first curve. We need to be at the first curve. Enter is yes. Did I jump to the second? Enter is yes. Do you want to guess? Yes, I do. And here is the answer. 3. X is 3, just like we thought. And that's how we can check our work with the calculator. And these are the 4 steps, the 4 possibilities that we might run into when we solve an equation using logarithms. And that's it for this video. If you have any questions, please let me know. Thanks a lot. Take care.